For solving logarithmic equations, such as the one written here, the standard approach would be to use the exponentiation with the same base, much like we did with undoing an exponential by using a logarithm with the same base. There are two forms of inverse property for logarithms and exponentials. One that we saw before was that if we have an exponential to start, that taking the logarithm with the same base results in the original value x, because performing any operation and then immediately performing that inverse operation cancels each other out. Well, what if the logarithm happens first and then the exponentiation happens afterward? Well, the true inverse is it doesn't matter which happens first and which one happens second. If we have subtraction, we can undo it with addition. And if we have addition, we can undo it with subtraction. So, same basic idea, these things cancel each other out. That is the rule that we are going to use here. So the standard approach would be to exponentiate each side using base 3. And it's actually very straightforward. So again, what happens here is the base 3, the exponentiation base 3 and the logarithm base 3 cancel each other out and leave us with simply the x plus 1. And on this side, we can actually evaluate that actually fairly easily. Just pop it in your calculator and go. 3 to the 5th is 243. Well, all we have to do then is finish out the equation. Now, you will often have fairly large values for the solution to a logarithmic equation. Remember, logarithmic functions grow very slowly. They all pass through 1, 0. But once they do, they tend to flatten out very quickly. It takes a very, very long time for this to get up to a y value of 5. I mean, we're looking at base 3, which means by the time we get out to 3, we're only at a y value of 1. By the time we get out to 9, we're at a y value of 2, because 3 squared is 9. To get up to a y value of 3, we need to be all the way out at 27. And then to get to a y value of 4, we need to be all the way out at 81, because 3 to the 4th is 81. So to get up to a y value of 5, we need a pretty big x value, then accounting for a small shift. So don't be surprised when you get particularly large values for the solution to a logarithmic equation. That does happen. It's the trade-off. With exponential equations, you tend to get a lot of wacky decimals, a lot of decimal places. With logarithms, that can happen, but the important thing is that the answer will be fairly large, and try not to be surprised by that.